Dear students, in last class we learned from large sample test chapter test for population and test for equality of populations, where two different locations were studied. And today we'll discuss and we'll learn test for proportion, that is test for proportion of the population. So whether sample population and estimated population, they both matches or not, whether hypothesis should be rejected or accepted, that we learn by solving the problem. Now I will take a problem from the textbook. So page number 240, problem number 16, I will read. In a random sample of 1,000 persons from a large population, 470 are women. That means here 470 are women out of 1,000 total people. So in that location 1,000 people are living, and out of 1,000 people 470 are females. And can we conclude that men and women are in equal ratio in the population? So they are asking that men and women are in equal ratio. Equal ratio means both are equal. 500 are men and 500 are women out of 1,000 population. If population is not 1,000, if it is beyond the 1,000, then equal proportion means they both are equal. That 0.5, 0.5 or 50%, 50%. So that proportion comes to 0.5. And proportion of this woman population is 470 divided by 1,000 is 0.47. So proportion of women as per the sample is 0.47, and they have estimated that both men and women are in the equal ratio, that is 0.5. Now the hypothesis. What should be the hypothesis here? H naught. Men and women are in equal ratio, that is P is equal to 0.5. So just in the question they have mentioned that they are in equal ratio. They never mentioned they are less than or more than. Okay, so the alternative hypothesis H1 is equal to men and women are not in equal ratio. So P is not equal to 0.5. So test statistics under H naught is Z is equal to small p minus capital P, that is samples proportion minus population proportion divided by root PQ divided by N. And here capital P indicates the population proportion, so that is here equal they have assumed. So capital P is 0.5 and samples proportion small p is equal to 0.47. Now what is Q? Q is equal to 1 minus P. So Q is equal to 1 minus 0.5 is equal to 0.5, and N is nothing but the total population they have taken here. So that is 1,000. Now let us solve it. Z is equal to P 0.47 minus capital P 0.5 divided by P into Q. So that is 0.5 into 0.5 divided by N is 1,000. So 0.47 minus 0.5 is 0.03 minus 0.03 divided by root of 0.5 into 0.5 0.25 divided by 1,000 is equal to 0.00025. 0.00025 that is equal to now find out the root for this value. Minus 0.03 divided by 0.00025 root is 0.0158. So 0.03 divided by 0.0158 is equal to minus 1.8987. 1.8987. So approximately minus 1.9 we can say here. Now here, is it one-tailed or two-tailed test? So since population proportion they have estimated is 0.5. Okay, if it is not 0.5, it may be less or may be more. Then also we can say it is not equal to 0.5. That is, it is not equal. Okay, it may be man may be more or woman may be more. Then also we say not equal. So this is two-tailed test. Okay, for two-tailed test where these figures will lie. And in the question they have mentioned at what percentage level alpha is equal to 0.05 they have mentioned. So 0.05 means 5% level of significance. So at 5% level of significance, the critical values are. So since it is a two-tailed test and 5% level of significance, for two-tailed test the critical value are plus or minus 1.96. 1.96. So if we draw it in the graph roughly, okay, so here I'll mark minus 1.96 and here plus 1.96. This is a 0 and our answer is minus 1.9, that is minus 1.89. So it is less than our critical value or K value. Okay, so that is Z calculation is sorry, it is minus, no, it will come in the negative side. So minus, so Z calculation is equal to minus 1.89. So which is greater than negative value. Okay, so since Z calculation lies in acceptance region, or minus 1.96 is less than Z calculation value and Z calculation value is less than plus 1.96. So since Z value lies in the acceptance region, these are rejection region. So Z calculation lies in the acceptance region. Therefore, H0 is accepted. That means here both men and women are in equal ratio. So since our Z calculation minus 1.89 lies in the acceptance region, here answer may be positive or may be negative. So in this problem answer is negative, so we should show it in the negative side, left side of the graph or curve here. Okay, so since this is accepted, H0 is men and women are in equal ratio. So once again I will repeat. So out of 1000 people, 470 are women, and here it is assumed that population proportion is, that is ratio of men and women, it is equal. So it is 0.5. Capital P is 0.5 and capital Q is 1 minus P, that is 0.5 again. So here my P minus P, 0.47 minus 0.5 divided by 0.5 into 0.5, that is P into Q divided by N, that is 1000. So 0.47 minus 0.5 is 0 minus 0.03 divided by, that is the root value of this figure is 0.00027 and that is 0.0158. So minus 0.03 divided by 0.0158 is equal to minus 1.8987. So that value lies in the acceptance region in the curve, or in other words we can say the critical value is plus or minus 1.96 since it is a two-tailed test and our answer lies in between those two values. Therefore the H0 is accepted, that is men and women are in equal proportion. Let us solve another problem on test for population proportion. Page number 240, problem number 17. In a election, the leaders of a party contended that they would secure more than 36% of votes. So, in the election, party members are participating and they are accepting that, they are telling that, or their estimation is they will secure 36% of the vote from that location. So that means capital P, population proportion is 36%. So, and a pre-poll survey of 400 voters revealed that the percentage is 42. So small p is 42% and n is equal to 400. Okay, so pre-poll surveyors met 400 voters and out of 400 members, 42% of the population people, they said they will vote to this particular party. That means capital P is 36% and small p, sample's proportion is 42% and the sample taken here is 400. And what they have asked here, does the survey support the leader's claim? Use 1% level of significance. So here, once again, I will read and explain here. In an election, the leader of a party contended that they would secure more than 36%. More than 36% they are expecting. Okay, so H0 here. H0, the party leader will secure 36% of votes. So capital P is equal to 36% or 0.36 and H1. So H1 is what they are expecting, that is they are expecting more than 36%. So the H1 is the party leader will secure more than 36% of votes. So P is greater than 36%. P is greater than 36% means here it is one-tailed test, and since it is greater than, it is right-tailed test. So one-tailed test and right-tailed. So here test statistic under H0 is Z is equal to P minus P divided by root PQ divided by N, and small p is 42%, that is nothing but 0.42, and capital P is 36%, that is 0.36. So therefore Q is equal to 1 minus P, so Q is equal to 1 minus 0.36. So Q is equal to 0.64. 0.64. So Z is equal to small p is 0.42 minus 0.36 divided by root of 0.36 into 0.64 divided by n is 400. So Z is equal to, so 0.42 minus 0.36 is equal to 0.06. That is a positive number. Okay, and 0.36 into 0.64 is equal to 0.2304 divided by 400. So Z is equal to 0.2304 divided by 400, that is 0.000576. If we find the root, we get 0.06 divided by 0.024. So Z value is equal to 0.06 divided by 0.024 is equal to 2.5. 2.5. And here at 1% level of significance, they are asked the critical value for 1% level of significance for one-tailed test is 2.33. Okay, so 2.33 at 1% level of significance. The critical value is 2.33. So since it is upper tailed test, it is plus 2.33. If it is lower tail, then it is minus 2.33. So plus 2.33. So let us so our I'll write a little here, 2.33. So this is K value, and this is the critical region. So this entire is acceptance region, this side. Now our answer is plus 2.5, which goes beyond 2.33. So our answer lies in the rejection region. So Z calculation is equal to 2.5 plus 2.5. So here, since Z calculation lies in the rejection region, or 2.33 is less than Z calculation plus 2.33 plus K value is less than Z calculation. That means here Z calculation is greater than critical value. Therefore, H naught is rejected. So H naught is rejected means H1 is accepted here. So H naught, what it tells, the party leaders will secure 36% of the votes. So that is not accepted here. Means H1 accepted, that is party leader will secure more than 36% of the votes. So what they have assumed is right. So therefore here party leader will secure more than 36% of votes. Okay. So here H naught is rejected. Therefore H1 is accepted, and H1 tells party leaders will secure more than 36% of the votes. So population proportion, what they have accepted is more than 36%. So 36% is the capital P, and out of 400 candidates, they 42% reveal that they will vote to this particular party leader. So small p is 42% or 0.42, and 400 candidates were met by the surveyor. So n is 400, and q is equal to 1 minus p, that is 0.64. So formula p minus p, samples proportion minus population proportion divided by root of pq divided by n. So 0.42 minus 0.36 is 0.06. 0.36 into 0.64 divided by 400 is 0.024. So 0.06 divided by 0.024 is 2.5. So this 2.5 is tested with 1% level of significance for one tailed test, and the critical value is 2.33. So in the diagram also, so our answer Z calculation lies in the rejection region, or our Z calculation is greater than critical value, H0 is rejected and H1 is accepted, and it tells the party leader will secure more than 36% of the votes.